we just understand the question, what the questions want to say to us. Okay, so uh, here the question is, if 3 cot A is equals to 4, check whether 1 minus tan square A upon 1 plus tan square A is equals to cos square A minus sin square A or not. Okay, so we just have to verify that this equation is valid or not, okay, by using the given fact here, okay, which is 3 cot A is equals to 4. Okay, so here we have cot and here we have tan, right? So we just simplify this first of all. Okay, so we just solve. Okay, now let's solve this question. So we have given that cot A, sorry, 3 cot A is equals to 4. Okay, this is given. So from this we can also write it cot A is equals to 4 upon 3, right? Okay, but we know that cot A is equals to what? Is equals to base with respect to angle A upon perpendicular with respect to angle A, right? So from these two equations, this, let me name this equation 1, this equations 2. So from equation 1 and 2, we can write that a base is a multiple of 4, right? So we can write it as 4k, and a perpendicular is equals to multiple of 3. Okay, so we write it as 3k. Okay, so that's very easy. Okay, now we have to find the value of tan here. Okay, so we must have to find the values of all three sides. Okay, for this we apply Pythagoras theorem. Okay, now by using Pythagoras theorem, we have that what? Hypotenuse square is equals to base square plus perpendicular square, right? So your hypotenuse square is equals to, what is the base here? The base is 4k. Okay, so 4k square, which is 16k square. Very good. Now the perpendicular is 3k, right? So it is 9k square. So we'll get 25k square. So now taking square root on both the sides, we have find that hypotenuse on this triangle is equals to 5k, right? Under root of 25 is 5 and under root of k square is k. So hypotenuse is our 5k. Sorry, hypotenuse is our 5k, right? By using this, we can easily find this relation. Okay, how we do this? let's see. Okay, so first of all, here we are given the 1 minus 10 square a upon 1 plus 10 square a, right? So 1 minus 10 square a upon 1 plus 10 square a, right? So let me just simplify this. So here we can write 10 is equals to sine upon cos, so it becomes 1 minus sine square a upon cos square a, right? Similarly, in denominator we have 1 plus 10 square a, so it becomes 1 plus sine square a upon cos square a, right? Now we just find the LCM. So here the LCM is cos square a, so we just multiply cos square a on numerator and denominator, and we get cos square a minus sine square a upon cos square a upon cos square a here, so it is cos square a plus sine square a upon cos square a. So we already know that if we have three denominators here, right? This is 1, okay, this is 1, this is 2, and this is 3. So what we do here, we just we just take the reciprocal of this last two denominators and we multiply it to our first fraction. Okay, so we will get cos square a minus sine square a upon cos square a multiplied by cos square a. Just have to reciprocal. Okay, so the denominator becomes numerator, numerator becomes denominator. So here cos square a plus sine square a, right? That's easy. Okay, now what we do, we just cancelled out this cos square a with this cos square a. We get cos square a minus sine square a upon cos square a plus sine square, right? Now we have to find the value of this is cos square a minus sine square. Okay, well, so that means the denominator becomes 1. Yes, and we have an identity like this, okay, which says that sine square a plus cos square a is equals to 1. So we just write it as cos square a minus sine square a. Hence proved. Okay, so that's our question. We can do it in two ways. Okay, so this is the first way here. We just simplify this thing and we will get the other side of the equation. Okay, we start with 1 minus 10 square a upon 1 plus 10 square a. We just simplify it and dash 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 dash, and we will we get this solution, which is of RHS, right? Here we find cos square a minus sine square. This is the one way, and another way we can also take the values on both sides and find the same thing. Okay, now, okay, so we know that 10a is equals to what? Perpendicular upon base, right? Similarly, we know that sine a is equals to what? Perpendicular upon hypotenuse, right? Similarly, we also know that cos a is equals to base upon hypotenuse, right? Now, just by putting the values, you get the value of tan A, sin A and cos A. Okay, so here the perpendicular is what? Here perpendicular, value of perpendicular is here, right? The value of perpendicular is what? Our 3k. So perpendicular is 3k upon base. Base is what? Base is 4k. K by k will cancel out and we have left with 3 by 4. Now similarly, for sin A, perpendicular is 3k and hypotenuse is 5k. K cancel out and we left with 3 by 5. Similarly, the base is 4k and hypotenuse is 5k. So kk will be cancelled out and we're left with 4 by 5. Okay, so now now that we have the values of all the three trigonometric ratios which is used in our equation, right? So what we have to do, we just have to put all these values in our equation. Okay, so first of all we just write our equation here. What is our equation? Like 1 minus tan square A upon 1 plus tan square A is equals to cos square A minus sin square A. Okay, that's our equation. Now by putting the values, 1 minus tan A is 3 by 4. Okay, so 3 by 4 square upon 1 plus 3 by 4 square is equals to cos square A. Cos square A. What is the value of cos here? 4 by 5. Okay, so it is 4 by 5 square minus sin square A. Sin square A is what? 3 by 5. Okay, so it is 3 by 5 square. We have to verify that LHS is equals to RHS. Okay, so here we come that 3 square is 9, it becomes 9. 4 square is 16, so it becomes 16 upon 1 plus 9 upon 16, right? Here it is 4 square is 16, 5 square is 25, minus 3 square is 9 and 5 square is 25, right? Similarly, so here we have to take the LCM. Okay, so here the LCM becomes 16, so we just multiply this 1 by 16 on denominator and numerator as well. Okay, so it becomes like this. Similarly here 16 upon 16 plus 9 upon 16, but here it becomes 16 minus 9 upon 25, right? Now what? Now here the denominator is same, so we can write it as 16 minus 9 upon 16, right? Similarly here the denominator and denominator, so we just reciprocal it and multiply it here. 16 upon 16 plus 9 is equals to what? 16 minus 9, which is what? Which is our 7, right? 7 upon 25. Here 16 will be cancelled out our, so we have left with 16 minus 9 upon 16 plus 9 equals to 7 upon 25. 16 minus 9 is 7, 16 plus 9 is 25, so 7 upon 25, hence proved. Okay, so in here LHS becomes equals to RHS by putting the values. Okay, so there is two method in which you can do this sum. Okay, and we have already discussed this whole two methods here, right? This method by putting the values is quite a long method, and this is the shortcut. Okay, if you have given this problem in the examination, then you must write this problem, solve this problem by using this trick. Okay, not by using this. Okay, so let's move on to the next question. So here is our next question, right? what our questions want to say. Let's find out. So question number 9. In triangle ABC, right angled at B, okay, we have to take a triangle such that B is a right angle. If tan A is equals to 1 upon root 3, we have given that tan A is equals to 1 upon root 3. We have to find the value of sin A cos C plus cos A sin C. Similarly, second, cos A sin C minus sin A sin C. Okay. So first of all, we have to draw a triangle, right? First of all, we have to draw a triangle. Okay. Solution. Let me draw a triangle by green color. Okay. So first of all, we draw a right angle triangle, which is right angled at point P. Here is a right angle triangle, right? Okay, just name the points here. Here becomes what? A. It is B because we have given that right angle at B, so we take this angle 90 degree as B. And the third one is C. Okay, so that's our right angle triangle, and we already know that this is what hypotenuse. This is our what perpendicular. This is our base, right? So now what? Now we have given that tan A is equals to 1 upon root 3. We have already discussed a lot of questions like that. Tan A is equals to 1 upon root 3, but we also know that tan A is equals to perpendicular for A upon base for A, right? So here for A, okay, for A, this angle, for this angle, we for this angle, this BC becomes what? Perpendicular, right? And this AB becomes base. Okay, similarly for this triangle, for this angle, sorry, this AB becomes perpendicular and this BC becomes base, right? Let's move on to our question. So here the perpendicular is equals to multiple of 1, right? So we just write let perpendicular is K. Okay, now from these two equations we have base is a multiple of root 3K, root 3, sorry. Okay, so we just write it as root 3K. Now by putting the values in our triangle, so we have left with this perpendicular, so that is this side BC is equals to what? K, right? Similarly, this side AB becomes root 3K. 3K. Okay. Now we have to find sin A cos C. Okay. So for both sin and cos, we must have the value of this AC. Okay. So we just find the value of AC by using Pythagoras theorem. By using Pythagoras theorem. Okay, by using Pythagoras theorem, we have perpendicular square plus base square is equals to what? Hypotenuse, right? Now perpendicular is what? Perpendicular is our 3K, right? Root 3K square plus this K, base is K, so it is K square, hypotenuse square. So hypotenuse square is equals to root 3K, which is 3K square, plus K square, which is definitely 4K square, Okay, so the hypotenuse becomes 2k, right? So we just find the value of hypotenuse, which is what? Root 2k. Okay, sorry, not root 2k, it is 2k. Value is 2k. Now for 1, okay, what is our equation here? We have equation sin A cos C plus cos A sin C, right? We have to find the values of sin A cos C, cos A sin C. Sin A cos C, sin A cos C minus cos A sin C. Okay, it is our equation, right? So here we have plus value. Okay, no problem. Just take plus here. Okay, let's do it. Okay. So here sin A, we have to find sin A, we have to find cos C. Similarly, we have to find sin C and cos A. So first of all, just find the values of trigonometric ratios like sin A cos C, cos A sin C, right? You have to find two ratios here. Sin A, for sin A cos A, sin C cos C. Okay, so let's move on to that first. Okay, so let's move on to that first. So we have sin A is equals to what? Perpendicular upon hypotenuse. So here we have perpendicular as k, hypotenuse is our 2k, right? Hypotenuse is 2k. So k will be cancelled out and the value becomes 1 upon 2. Similarly, cos A is equals to b upon h, base upon hypotenuse. So here the base is what? Root 3k and the hypotenuse is 2k. So k cancel out and the value becomes root 3k. Root 3 upon 2. Okay. Similarly, sin C p upon h. Okay. For angle C, the perpendicular becomes base and base becomes perpendicular. So here the perpendicular is what? Root 3k. And the base becomes hypotenuse is 2k. So k cancel out and the value becomes root 3 upon 2, right? Similarly, cos C b upon h, value is root k, because base becomes k here, right? So k upon 2k. So k cancel out and value becomes 1 upon 2. Okay, so here we have the needed values here. Now we just put it in our equation and find the values. Okay, so sin A is what? 1 upon 2, right? 1 upon 2. Cos C is what? 1 upon 2, right? So multiply by 1 upon 2 plus cos A is what? Root 3 by 2. Root 3 by 2. Similarly, sin C is root 3 by 2. Root 3 by 2. Now 1 upon 2 multiply 1 upon 2. Okay, so we have left with 1 multiply 1 is 1, 2 multiply 2 is 4, plus root 3 multiply root 3 becomes 3, and 2 multiply 2 is becomes 4, right? Similarly, we have common denominators, so we can write it as 1, so it becomes 1 upon 3 upon 4 is equals to 4 upon 4, which is definitely becomes 1. Okay, so the first equation has a value 1. Let me go for the second. Okay, so what is our second equation? Okay, the values is same, but the sign is inversed, because in first we have plus sign and in second we have minus sign. Okay, So let's move on to that. So sine A cos C minus cos A sine C. Okay, so here the sine A is 1 upon 2, cos C is 1 upon 2 minus cos A is root 3 by 2 multiply sine C is also root 3 by 2. Similarly, this becomes 1 upon 4, this becomes 3 upon 4, which was 1 minus 3 upon 4, and then value becomes minus 2 upon 4. 2 2s are 4, so value becomes 1 minus 1 upon 2. Right. So this is the solution of our second question. Okay, I hope you got it here. So let's move on to our next question, right, which is question number 10. Okay, so we have our next question here. Question number 10. In triangle PQR, right angle at Q, PR plus QR is equals to 25 centimeter and PQ is equals to 5 centimeter. Determine the values of sine P, cos P and tan P. Okay, so here we have given a right angle triangle which is right angle at Q. Okay, and we have given the sum of two sides which is 25 and the third side which is equals to 5 centimeter, and determine the values of these three trigonometric ratios cos P, sin P and tan P. Okay, so first of all, solution. For solution, we must need a triangle here. Okay, right angle triangle which is PQR. So first of all, draw a right angle triangle here. Let's guess this is a right angle triangle. Okay, just name it as PQR. PQR. Okay, so here is our triangle PQR which is right angle at Q. Now we have given that PQ plus QR is equals to 25 degree, right? So PQ like this and QR this. Okay, the sum of these two sides is 25 degree. Just write it down here. PQ plus QR is equals to 25 degree, 25 centimeter, right? Not degree. 25 centimeter. 25 centimeter, right? Now we are given PQ is 5 centimeter. PQ, sorry. Okay, so we have drawn the right angle triangle which is right angled at Q. Now we have given that PR and QR, the sum of PR and QR is 25 degree, right? 25 centimeter. So PR is our what? This. Okay, and QR is our this. The sum of these two sides, PR plus QR, is equals to 25 centimeter. Okay, and the side PQ is 5 centimeter. This side PQ is 5 centimeter. Okay, now we have to determine the values of sine P, cos P and tan P. Okay, for this, so we must find the values, corresponding values of these two. Okay, so how can we find it? We just know a bit of algebra here, use it. Okay, so from this equation we can write as PR is equals to what? 25 minus QR, right? We can write it as like this. Now we just use Pythagoras theorem here by using Pythagoras here we have what? H square is equals to perpendicular square plus base square. Okay, here h square is equals to perpendicular. Okay, so here uh, for angle P, the perpendicular is QR, right? Perpendicular is QR, so here we QR square plus base. What is base here? Base is this, our PQ, which is what? Just 5 centimeter. Just 5 centimeter. Okay, 5 centimeter whole square. Now h is PR. Okay, and we have the value of PR here, 25 minus QR, right? So we can write it as 25 minus QR's whole square is equals to QR square plus pi square, which is 25. Okay, now we just use an identity which says a square, a minus b whole square is equals to a square, so 25 square plus b square, which is QR square, minus 2ab, so 2 multiply 25 multiply QR, okay, equals to QR square plus 25, right? Now it's 25, so here QR square and QR square will be cancelled out. We have left with 1 25 square, which is 625, and this 25 becomes minus 25. Minus 25 into 2 is 50 into QR is equals to 0, right? Now 625 minus 25 is 600 minus 50 QR is equals to 0. So 50 QR is equals to 600, right? Similarly, QR is equals to 600, 1600 divided by 50, right? So 0 0 will be cancelled out. The 5 multiplied 12 is 60, so QR becomes our 12. QR becomes 12, right? So this is our 12 centimeter, and if this is 12 centimeter, then our PR becomes 25 minus 12, which is 13, right? 13 centimeter. Okay, now we just find the values. The first value for sine P, which is equals to perpendicular upon hypotenuse. So here the perpendicular is what? For P, the perpendicular is QR, which is 12 centimeters. So 12 upon hypotenuse is 13. So 12 by 13. Similarly, for cos P, here we have the formula base upon hypotenuse. So B, what is base here for P? Base for P is 5 centimeters. So here we write 5 upon hypotenuse is 13. So 5 upon 13. Similarly, for 10 P, we have P upon B, which is perpendicular upon base. So here the perpendicular is 12, the base is 5, so it becomes 12 upon 5. Okay, so our question is completed here. Now let's move on to the next question, question number 11. Okay, so what is our question number 11 here? State whether the following are true or false. Okay, we have to say that the following sentence are true or false. So the first one here, the first one is the value of 10a is always less than 1. Okay, so we have already studied the table which consists of the values of trigonometric ratios. Okay, So by observing the table, you can easily answer that the value of 10a is never greater than 1. Okay, it's always less than 1. So no, always less than 1 का है, ठीक है यहाँ पे. Here it says always less than 1. Okay, not 1 even. Okay, but we know that 10a 1045 degree is 1 and 1060 degree is what? 1060 degree is root 3, which is also greater than 1. So this statement is false, wrong, right? Now the second one, sec A is equals to 12 upon 5 for some values of angle A. Okay, so here we have given that sec A is 12 upon 5 for some values of angle A. Is it possible or not? Okay, so we know that sec A is what? Sec A is what? Sec A is inverse of cos, which is hypotenuse upon base, right? So it means hypotenuse is 12 and the base is 5, multiple of 5. Okay, is it possible? Yes, it is definitely possible. We know that we have a Pythagorean triplet as 5, 12 and 13, right? So yeah, yes, it is possible, but for this we have hypotenuse is 13, but here the hypotenuse is 12. Okay, which is smaller than our second side. So we cannot say that it is possible. Okay, it is not possible. Cos A is an abbreviation used for cosecant of angle A. Okay, we already know that it is true. For cosecant of A, we use cos A. Cot A is a product of cot and A. Okay, is it true or not? Definitely not. Okay, here cot A represents that cot is nothing but a name given to the ratio. Okay, so here for cot A, it says that the ratio of base and perpendicular of for this angle A. Okay, it does not mean that the multiplication of cot and A, so it is wrong. Now sin theta is 4 upon 3 for some angle theta. So sin theta is 4 upon 3. Is it possible or not? Definitely not, because sin theta is what? Sin theta is perpendicular upon hypotenuse. Okay, and we already know that for any right angle triangle, the hypotenuse have the largest value. Okay, but here the perpendicular is bigger than hypotenuse, which is not possible. So this is wrong. Okay, so that's all for today. I hope you understand all the questions, all the 4 questions, and if you have any query, then please comment down below, and I will definitely answer it in our next lecture. In our next lecture, we will start exercise number 8.2. Okay, so that's it for today. Goodbye.